Peter Garnavich from physics. The revolution continues.
Well, thank you all for staying. So, a helium atom walks into a bar. The atom says to the bartender, "I think I've lost an electron." The bartender says, "Are you sure?" And the atom says, "I'm positive." If you found that joke lame, you are probably made of atoms. Atoms are everywhere. In fact, we take them for granted. They are us. We have water, we have DNA. They're wonderful things because they make complex interactions, allowing big things to be built from them, including people. But what I'm going to talk about tonight, and if you take anything away tonight, is that atoms are actually rare in the universe. It's easy to think they're common, but in fact, we live in a special place. And atoms are actually one of the least important parts of the universe. I could name two things that are more common in the universe than atoms. The realization that we are not made of the central stuff of the universe is part of a revolution that started 500 years ago, wrong one, with Copernicus. Copernicus was looking at planets and trying to figure out what was going on with them. And if you look up at the sky, probably right about now, unless they've set, you could see Venus and Jupiter. And I just noticed a few days ago that they actually switched positions. And in the pre-Copernican view of things, that was not very easy to do because we were at the center of the universe. And Copernicus went and realized it would be much easier to explain the motions of the planets simply by putting the Earth to one side of the universe and putting the sun in the center. And that is the start of a revolution, as I said, that has been continuing now for the last 500 years. And in fact, I just noticed Copernicus actually started writing his theory down, the revolutions of celestial spheres, back in 1514, almost exactly 500 years ago. He didn't publish for another 30 years or so. It's kind of a dangerous thing to be writing down. But he eventually did, and fortunately, we have his model for the solar system, which was his universe today. Of course, it took a long time for this to become accepted. In fact, I'm always surprised there are people today that don't accept the idea that the sun is the center of our solar system and the Earth is not the center of the universe. Are there any of those people here today? They probably left earlier for getting late. The revolution continued. 100 years ago, we thought that our universe consisted of a bunch of stars. There were no galaxies back then. The idea of a galaxy hadn't been invented yet. 1912, we were in the Milky Way, just a pile of stars, and Harlow Shapley studied clusters, and he mapped out, by measuring the distances to these clusters, the fact that clusters of stars in our galaxy did not focus on us. They weren't surrounding us. They were surrounding a spot about 30,000 light years away from us, and he concluded that was the center of our Milky Way, and that we are actually out in the suburbs. We're in the South Bend to the galactic Chicago, if you will. Again, we are not in the center of the universe. Harlow showed us that. Our universe, back then, the Milky Way, we're quite far from the center. Things started happening quickly around Shapley's time. Edwin Hubble, in just a few years after Shapley, realized by measuring distances again that these fuzzy blobs called spiral nebulae are actually very distant and as large as our Milky Way galaxy. That, again, moved us out from our central little object here, our Milky Way, and made us ordinary. We're just another galaxy in a universe filled with galaxies. His second big thing, just a few years later after that, 1929, Hubble realized that those galaxies that he showed existed way out there are all moving apart. They're moving away from each other. The universe is expanding. And it's very easy to visualize this. Well, it's easier to do it on a big screen here. So here's a piece of the universe here with galaxies floating around, and the universe expands, meaning the universe gets bigger. So I could just do that by clicking a switch. So we're moving back and forth 1 billion years in time. The universe expands, everything gets further apart. But when you think about it, say this is our galaxy here. If you look, all the galaxies are getting further away from us. The further away they are, the faster they're moving away from us. But it looks as if we're the center of the universe. So it's easy to think we are because it looks that way. But in fact, if we were to move to a different galaxy, say this galaxy over here, and look at the galaxies around us, we'd find, in fact, that those galaxies all look like they're moving away from that galaxy as well. Everybody sees the same thing. There's no special place in the universe. There's no center to the universe. So we can't be the center of the universe because there's no center. And as I said, things move rapidly. Back in 1998, I was part of a team, the HISE supernova search team, and a competing team, the Supernova Cosmology Project. We actually, our team won the Nobel Prize last year for this discovery. And the discovery using supernovae, and here's a little a supernova next to, this is a nearby galaxy. What we did was we measured supernovae in distant galaxies. It turns out this expansion of the universe is expected to actually slow down. So matter in the universe, which atoms are some, but there's also dark matter in the universe, and that's really boring matter because it doesn't actually interact with itself or ordinary matter. But that two combinations of dark matter and atoms is expected to slow that Hubble expansion down. And we decided we would try to measure that by measuring very distant supernovae and seeing if the expansion rate in the past was different than it is today. And well, what we were expecting to find is how much the universe had slowed down, a deceleration. And what we were surprised to find, and why we're standing in Stockholm with a bunch of people holding gold, is that, in fact, the universe is not slowing its expansion down. It's actually accelerating, the opposite of what you expect the universe to be doing with matter alone. And from that, we concluded that, here's a little model here. We expect maybe matter is slowing the universe down. It could actually recollapse. Or if it's not very dense matter, it could slow the universe down and continue to expand. But what we found was the universe was actually accelerating. And this is a big surprise, but Einstein's equations actually show if you take energy and spread it evenly across the universe, even a small amount, because it's everywhere, this energy, there's a little bit in this room right now, that energy is going to actually turn, instead of pushing or pulling the universe together, it actually pushes the universe apart. So what we found was, in fact, 3/4 of the universe is made of this dark energy that we still don't exactly know what it is, but it's a uniform distribution of energy. And we still had that dark matter that we were actually trying to measure, and that atoms actually make up only 4% of the universe. So the big thought I want you to take away, as your parents used to tell you, you're not the center of the universe, okay? And in fact, you're not even made of the stuff that most of the universe is made of. If we were to continue this natural Copernican revolution, what do you think the next step would be? We live in a universe, we're not the center of it, we're far from important. Probably the next step is that we're not even the only universe. Probably there's a multitude of universes that we have no contact with, and they all have different amounts of dark energy and different amounts of atoms, or no atoms at all, and no people to really discover what that universe is about. So on a more positive note, let's think we are that 4%. We actually make up some part of the universe, the atoms that interact and produce complex atoms and DNA and people, and we can actually think and realize what's going on. And so to end on a positive note, atoms, that is us, are the means by which nature strives to understand itself, paraphrasing George Bernard Shaw. Thank you.
Thank you very much.